guys, Lenny with Dynomite Diesel Products. So I have 19 nozzles in front of me, and I'm going to talk about a description of what these nozzles are, from good, the bad, the ugly, and some pretty awesome stuff as well. We're going to start at number 19 and we're going to work our way back to number 1. So if you got to break this up into 2 sections to watch it, I don't blame you. But these are just things. We've got a bore scope. It's hooked up to a computer and a monitor on our wall. We take these images. A lot of these things are things that come in from different machine shops. A lot of these images are things that come in from daily driving trucks. And some of these images are actually from stuff that we do here in-house. And I just wanted to kind of walk you through all of them, talk about characteristics and why they're actually here, and the importance of like what this means to you. So you as a truck owner, you go to the diesel injection pump, you grab the handle and you pump it in there, and you don't test the quality of that fuel. Now, if you're pumping fuel into a metal tank, aluminum, steel, anything like that, there could be things that break free from the fuel tank and then work their way through the fuel system. If you've got a water filter / water separator, and that thing happens to be like 75, 90, maybe 100% full of water, that's great if you drain it, because you drain it and then it fills itself with diesel again, and you begin to filter the diesel. But if that water if the separator / filter is completely full of water, then everything bypasses over the top and you're not filtering anything. So number 19 on the list is going to be a nozzle that basically is just a Bosch nozzle that's been totally contaminated, and you can see all the rusty chunks in there and all the stuff because the water separator was full, it bypassed, and everything else past that just goes right through that separator / filter, and then into your fuel system it goes. You come back and you need $4,000, $5,000, $6,000, $7,000, $8,000 worth of fuel injection parts. And that being said, this is why we're supposed to be running our water separators, all right? Now, number 18 on the list, this is just a stock nozzle that was damaged due to some sort of a pump malfunction prior to the fuel filter. So CP3 pump started to fail, something in the lift pump might have failed, and we ended up with a bunch of metal that's stuck inside there. And that metal substance that you see is actually right in the needle guide area, and there's only 2 microns worth of clearance between the needle guide and the nozzle. So you can imagine how small those particles are, but that surface finish that's right there is allowing all sorts of leakage, and the needle valve is getting stuck and hanging up on that. So that's number 18, not good either. Now, number 17, this is a 6-hole nozzle with lots of very small particles in there, and that 6-hole nozzle would have come from like an LM, anything with a CP4, Chevy Duramax stuff CP4. So basically what happens, CP4 starts to fail, and it outputs a bunch of metal into the injection system. So the line's got to go, the injector's got to go, the return system's got to get cleaned out, the fuel tank's got to get cleaned out. It's a big catastrophe whenever that happens. So this is something that happens to the CP4 trucks. Number 16 on the list is another Bosch VCO nozzle with lots of metal debris and contamination. And at about the 10 o'clock position, you can see a large chunk of trash that's been smashed by the needle valve. And that needle valve will just hang wide open, and you'll get lots of white smoke and things like that at idle. Number 15, this was something that was EDM'd, electro discharge machined, by another EDM operator, not us. This was supposed to be a P570 sack style nozzle for a 12 valve that was EDM'd at 18 thousandths of an inch. I had these done for me years ago, and the EDM shop that did them, what would happen is they come through the nozzle with the tungsten, and in this photo at, let's call it the 7 o'clock position, you'll see a tag mark that's 180 degrees opposite of the hole that I would call hole number 2, which is on a clock at about number 2. And basically that tungsten comes clear through the nozzle. It goes through, it's about 47 thousandths worth of steel, and then they reached another probably 100 thousandths and then tagged up into the seat area of that nozzle. And when the needle valve comes down in and it hits that repeatedly, it impacts those high parts and it splits the nozzle wide open. So this is the kind of aftermarket EDM work that we're really not in support of around here. It's really bad stuff. So that was number 15. Moving on to number 14. This is an extrude hone dual plane nozzle. And the reason why I wanted to bring this up is because with the dual planes, you end up with a high-low pattern. You can see it on the outside of the nozzle. Some of the 6.7s and some of the Duramax stuff use this. The nice thing about this is it gives you a bit more real estate from the factory to try and get all 8 holes in there. But when you extrude hone them too hard, like this one here was basically honed a little hard, you end up with holes that basically touch one another. And that 360-degree shroud around each one of those spray orifices is being shared by the other hole. So these things end up with all sorts of funky, goofy spray patterns and things like that. As far as big power guys are concerned, this thing's never really been a super desirable nozzle. Putting whatever hole count you have, we start with blanks, we can put 6 holes in there. 6 larger holes will definitely outflow 8 smaller holes. But when you're stuck using factory parts, OEM parts, and you're just trying to gain massive flow, this number 14 nozzle is the kind of tricks that people would use on dual plane stuff. 5 years ago, it was acceptable. Today, it's not really acceptable. Just be aware of that. Now, number 13, this is a 6-liter nozzle that was on its 2nd round of life. There's a very large name in the diesel injection business that replaces about 30 or 40% of their nozzles on their remans, and they reuse about 60 or 70% of the nozzles, and they wash them, clean them up. But then you can see just above the spray holes, down in the very pocket there, there's a bunch of cancer, like electrolysis looking stuff. And basically the needle valve is a really good material. It's very hard, and it goes down in there and it closes and opens and closes and opens, and it's just a microscopic jackhammer. Well, over time, the needle starts to break away at the seat. Now, like I say, this nozzle is on its 2nd run at life, and when you buy this brand of reman, you'll have issues right out of the gate because you'll drop a brand new reman in there and they just don't run correctly. They've got smoke issues, all sorts of bad stuff. You can send the injectors in, we'll take photos like this. We have to replace these nozzles. Once the nozzles are replaced, Bob's your uncle and down the road you go. Everything's good. Number 12, this is a little bit of a different picture. On control valves for all the common rail guys, this is the seat where the check ball stops and closes. And in this seat picture, you can actually see that there's some debris down in the 4 o'clock and 6 o'clock position. And outside of that debris on going towards the center, you've got a bunch of irregular round marks. And you can see that that check ball has 1, 2, 3, 4 different positions where it's kind of tried to reset and live its life. And then since the check ball is leaking, outside of that you see striations that basically look like sharp pointy marks that are heading all the way around the check ball because it's been leaking for a good long time. So those are the kinds of things. Whenever we remanufacture injectors, common rail injectors, we always replace the control valves because of this. A nozzle traditionally will outlive life-wise a control valve. So if you've got a used set of injectors and you're wanting to remanufacture them, buying nozzles is not the way to go. This check valve wears out before the nozzle usually. Just be aware of that. It's kind of a heads up. Picture number 11. This is something that, what happened here, an end mill was used, and they use the end mills at like 40 and 50,000 RPM, so you get a really nice, clean drill hole. But what happened is this is an elliptical pattern, so like a 12 valve style head. So you look at it and you kind of see that it's all cantankerous and wonky, and that's based on the fact that the injector goes in the head at 20 degrees of an angle. So to get the spray pattern in the bowl correctly, it has to be in this elliptical form. What I really dislike about this is at the 6 o'clock position, you can see that there's a big hanger of steel that is needing to be broke free, and it needs to be knocked out and cleaned up and then shoved out, which extrude hone could do that. But you see the hole number 1, 2, 3, 4, 5, hole number 4 and hole number 5, which would be like the 8 and the 10 o'clock positions. Those holes are actually intersecting. So the shrouding that's supposed to be around those spray holes is not there. And for anybody who's ever done any cylinder head work, you know that shrouding around a valve makes the valve flow very, very well, and no shrouding does not allow the valve to flow very big at all. So even though these spray holes are really large, they're just not going to be as efficient as they could be because they are touching and intersecting. And in this case, you've removed so much bloody steel that with really high injection pressure, you're going to end up with a cracked nozzle at some point. So this is something that we use this bore scope daily whenever we're EDMing, and we basically give ourselves X amount of room, but anything more than that, we try and work on something totally different. And again, if you're using an OEM part and you're trying to modify it, these are some of the challenges that you end up facing. Now, hole number 10, this is an aftermarket common rail nozzle. You can see down at let's call it the 6 o'clock, maybe 7 o'clock position, there's lots of grinding marks that are kind of swirly inside there. And that isn't great because the needle valve is going in there and it's trying to close on that stuff. And since the grinding was done in the aftermarket world really fast and not very accurately, the needle valve is going to leak chronically on this thing. And if you look at the hole at the, say, 10 o'clock position, you can see that there's a pile of metal just inboard of the spray orifice. And the other hole right next to it, let's say that that's at 1 o'clock position, that hole is starting to get a little bit of K factor. So somebody made this thing and they used some form of abrasive flow machining or extrude honing, but they weren't using very much of it. So they must have achieved their total flow rate with almost no AFM work whatsoever. It's really not, this is not a good part. They are very cheap. We can buy these things for $17 all day long, every day if we choose to, but that is something that we can't even fix here. It just wasn't manufactured correctly, so we would never use these things. But some of the aftermarket remanufacturing injectors that are cost effective, let's call them cheap, I hate to use that term, but this is the kind of quality of part that you get on that stuff. Now, number 9, picture number 9, is actually a 12 valve nozzle with just massive amounts of rust inside of it. Self-explanatory. If you have bad fuel, if you don't store your fuel properly, if the truck sits for way too long with moisture in the fuel, this is the kind of stuff that you're going to end up with. And believe it or not, that is just a massive growth of rust stuck down inside the pocket of a 12 valve nozzle. Now, next, hole number 8. This is an aftermarket nozzle that had just a little tiny bit of AFM run through it, and it actually worked out pretty good. You can see that there's a little bit of K factor developing on all of the spray orifices, and when I speak about the shrouding, you can see how much room there is in between all the holes. Truthfully, this isn't a bad part. It's actually a pretty good part. And then I'm going to jump to hole number 6 right now. And the reason why I'm doing that is because on number 6, it's the exact same part, but we extrude honed it with some media, and we added more K factor, and we got more flow out of it, but we left a lot of shrouding there. So this is going to be a very, very, very efficient spray orifice, and it's going to turn out really, really nice. So when we didn't have blanks, this was the kind of results we were achieving and shooting for. And because of that, we've always had good, reliable parts. But this bore scope has helped us gauge that and throttle that correctly. So that was number 8 and that was number 6. Now we're going to jump to number 7 and talk about that. And this is just more aftermarket EDM work. This is, it's not good. This would be the kind of stuff that you see in the tractor pull world. Big holes, people talk in hole size. They don't talk about flow. We've been pulling these things in and pulling them off the service or out of service here for a couple of years. This is the kind of stuff that we can get a much smaller hole to break up and atomize the fuel a lot better. And the more atomized something is, the smaller the droplet size is, the better the burn pattern is going to be, and the faster the burn rate is going to be. And if you're really trying to make horsepower, what you need it to do is flash on and flash off as fast as possible. With poor atomization, that time isn't really going to flash very quickly. So this is just stuff that we're really not ever going to get into or be a part of or do. Now, at this point, I've got the next 5 to go. And what I'm gonna do is we're gonna talk about hole number 4 first. Now, this injector was an OEM part that was stored, and whatever they used for calibration oil, basically however long it sat on a shelf or in the injector, when the injector was assembled, it was stored with contamination in, just a little bit of moisture was in that calibration oil. And at the 3 o'clock position, you can actually see that there's a rust area right there. Now, given the fact that this was a brand new part, we wanted to show it to you and show you that proper storage is really correct. So whenever we manufacture an injector here, we fill the nozzle with WD-40 because it's water dispersing, and 40 was because they got it on the 40th revision, so that's where WD-40 actually comes from. But we store nozzles with WD-40 in them to prevent this kind of stuff from ever happening. Now, I'm going to jump to hole number 5 at this point. And this is just an OEM EDM job. Now, back in the old day, this injector nozzle was used in the late 90s, and EDM work was high quality. It was good stuff. The way that they would rewrite those recipes today, if they had today's technology back in the late 90s, they would end up doing some sort of extrude hone or AFM work. Now, what I'm going to do is jump to number 3, because this is the exact same nozzle with some extrude hone media run through it. And in this view, you can see that we've got K factor, or that bell that's feeding into that spray orifice. So it's the exact same nozzle. And because of extrude hone is a very thick, almost like children's silly putty consistency, it polishes things up and makes them look beautiful. So you can see that the finish down there, we've gotten rid of that kind of tannish color. It's just polished, it's faced like a mirror. Now, extrude hone is a really, really, really good product, and it works very, very, very well. But with AFM, jumping to hole number 1, this is the exact same nozzle. We started with the stock EDM work, we extrude honed one of them, and now we're on hole number 1, which is AFM. Abrasive flow machining is a lot like extrude hone, except for extrude hone is that thick, putty, silly putty kind of a stuff. AFM is a much more oil-based material with a cutting agent that's suspended in the oil, so it pours a lot like water. When it flows through the spray orifice, really the only spot that it works on is the entrance into that spray orifice, and AFM is something that's extremely challenging to get correct. We do a lot of testing around here before we write recipes. AFM can make you or break you, and it's very, very frustrating to get it correct. But this is a vision of what a perfect AFM job looks like. Now, inside of an AFM's hole, the steel ends up looking a little bit like the bird's feathers. So a bird's feathers kind of stack one on top of another, and then if you pour water down it, it sheds down those the feathers. It won't pour the other way, but it always goes with the flow. AFM is really, I'm learning a lot about AFM, and it's a different material, because what's happening is with extrude hone, we were polishing the inside of the holes and making it just a mirror finish. And we thought that was as good as it could ever get. But after having an AFM for a couple of years, I'm learning that AFM, the way it works, is actually more efficient than some of the extrude hone stuff. So depending on hole orifice size, we choose AFM on, we're getting to be probably about 80 or 90% of the holes now. But once you get above a certain diameter, the AFM flows through so fast it doesn't really do much work. So then we would go back to extrude hone and use extrude hone on the really large stuff. But that's something that, with all these recipes we've got, having both methods in-house, it's perfect for us. So we do a lot of testing. I can't promise you which injector, which style you're going to get with your injectors, because I don't know which injector you're going to purchase from us. But both those methods are, the way we use them, I think that it's as good as it's ever going to get. And we've just testing all the time. Now, hole number 2, I saved this one for last because basically this is something that we've patented here. We've got 5 spray holes that are, I'm going to tell you, those are about 14 thousandths of an inch. But we've ran AFM through them, and then we've added pilot holes. Now the pilot holes, basically how our patent works is whatever the original spray holes are, we come in at 50% diameter, and we then make 2 spray holes to act as pilots. And you can see that those pilots are elevated a little bit closer to the piston, and they're a much smaller diameter to help atomize at low injection pressure the fuel. So in this application where a 12-valve P-pump truck is concerned, you might start this truck on a really cold day with normal nozzles and they have an idle haze, they kind of stumble and fumble, they're a lower injection pressure, the spray hole is very large so you can get the low injection pressure to get the proper quantity out there. But what we're doing on our small street driven stuff is we're adding pilot holes to help atomize that, and it really helps bring you off the stop sign. If you've got to jump into traffic, you don't have to roll into the gas pedal near as hard to make all the injection pressure. The pilot holes help atomize and start a pilot injection event, and as that burn begins, it also helps ignite the primary fuel. And when you stand on the gas pedal and really start making a big quantity and a lot of pressure, the other 5 spray holes take over because path of least resistance. Path of least resistance basically says that when you start to really stack the quantity to it, those 5 spray holes are going to take over, and they're going to be the ones that are actually in charge of making all the horsepower. So this is just, in our opinion and in our testing, about the best that you can actually get out of a street-driven mechanically style injector. So we've got this done on 7.3s. We got it on, actually we're using pilot holes on quite a bit of stuff. Common rails with the injection pressure and the fact that you can vary timing from idle to mid-range to wide open throttle. You don't necessarily need pilot holes, but with the mechanically injected stuff, the pilots are really, they're showing that they're really being just glorious for us. So I'm open to any questions and what have. So if you guys want to shoot us an email, send your questions to Dynomite Diesel, just sales@dynomitediesel.com. And those guys will print them, they'll come see me, and we'll get you questions answered. Or if you want, you can just jump in the comments below and we'll take a look there and answer any questions. But I hope this gives you a little bit better idea on what it is we do here at Dynomite Diesel, and just the inside view of what it is we look at every day. Thanks guys, Lenny Reed, Dynomite Diesel Products. See ya.